Alright, so here's section 6.2. We're not just identifying what's in what set, but now we're actually counting the numbers of things in a given set. This is all to build up so that we can do probability, where we compare number of total out of the number of desired out of the number of total things that we have. So before, our notation was, let's say A intersect B, and that was for when there were two sets and we wanted their intersection. Now what we're adding is this little n. That means the number of things. So that should give you an actual numerical answer. Alright, so we need to have something like a 5 there, or some sort of number for our answer. So if two sets are disjoint, this is the easy case, but for the sake of completeness, disjoint means that they are they never even overlap. There's nothing in one set that's in the other. Alright, so if I have set A and B, and there's 5 things in A and there's 6 things in B, then A union B is the number of things in A plus the number of things in B, so that would be 11. Alright, pretty easy. So there's our formula, just the number of things in A plus the number of things in B. That's what the notation means. So the number of things in, actually wrote that a little incorrectly, number of things in A union B equals 11. Piece of cake. So now, what if they're not disjoint? We get this formula. Alright, so we have to subtract the intersection. Let's see why. So if I count, let's say we have A is a set of 5 things, and B has 6 things in it. But let's say that there are 2 things that are in A and B, so that's the intersection. Alright, so there's 2 things that are in the intersection. Well, of those 6, we've already counted 2, so there's 4 that are in B but not in A. And there are 5 things in A, but we already counted 2 of them, so there's 3 that are just in A, not in B. Well, if we look at the Venn diagram, here's all the things that are in A, so if I count that, that's 5. Here's all the things in B. If I count that, that's 2 plus 4 is 6. But I've counted this 2 twice. Right? So clearly, the total number of things that are in A and B together are 3 things plus 2 things plus 4, which is 6 plus 3 is 9. Alright, so the number of things in A union B should be 9. We said the number of things in A are 5, the number of things in B are 6. Because, see how it overlaps, the blue is over the red? We've counted that twice, so we have to subtract one of those double countings. So we have to minus the 2. And then 5 plus 6 minus 2 is 11. That makes sense. Alright, so let's try another example here. There is a B here and a B there. Oh, nice color. And they also share a D. So those would be in the intersection. B and D. There's an A, a C, and an E, and that's not in B. And then F and H here. That's in F, I swear. Alright, so now if we look at the number of things in the union, that's one, the other, or both, that's going to be 1, 2, 3, 4, 5, 6, 7. So that's 7. Number of things in A is clearly 5. And the number of things in B is clearly 4. So we have 5 plus 4, but there's 2 in the overlap, there's 2 in the intersection. So we have to subtract 2, and that would give us 9 minus 2 equals 7, which is the same. So that proves our formula here. Alright, so that's one formula. Here's another type of problem we can have. So a survey of 100 coffee drinkers. So that's our U. Number of things in U is 100. Alright, that's our universe, all the people in the survey. It was found that 70 take sugar, so we'll have S be the set of people that take sugar, and C will be the set of people that take cream, and the number of people in S is 70, and the number of people that take cream is 60. And it says the number of people in the intersection that take both sugar and cream is 50. Anytime you're filling out a Venn diagram, you fill in the intersection first. And if there's multiple sets, like something like this, you fill in where they overlap everywhere first, if possible. So there's 50 people that take both sugar and cream. That leaves, since there are, sometimes I like to write a little number next to the total, or the total for the set here, but don't include that as part of your Venn diagram. So C is 60, so I'll write that to remind myself, and S is 50 total, or I mean 70 total to remind myself. So we've already counted 50 of the sugar takers, so there's 20 that take sugar that don't take cream. And of all the people that take cream, 50 take both, so there's 10 people that take just cream, no sugar. So if we wanted to know how many take one, the other, or both, we can either just use our formula, which says that it's number that take sugar plus the number that take cream minus the number that take the intersection, which would be 70 plus 60 minus 50, which is 130 minus 50, which is 80. Does that make sense to this Venn diagram, which I know the Venn diagram's right? 20 plus 50 is 70, plus 10 is 80. So we get the same thing. The union, remember, is the one that takes one, the other, or both. So that would be our union. Now, how many people drink it black? Drink it black is the same as the complement of the union, right? If they drink it black, they don't take sugar, they don't take cream, and they certainly don't take both. So we're looking for the complement here. So that would be the number that's in A union B complement. Or we can just look and say there's a total of 100, 80 of them take something, so 100 minus 80 is 20 that take nothing. So we've got to marry the notation with the Venn diagram with the actual algebra to find the numbers. All those things I want you to understand in that holistic manner. So cream only. Cream only would be the people that are in the cream Venn diagram, but not both, right? Just cream, not cream and sugar. So that would be 10. So this would be 10. We said it was 20 people that take it black, and anybody that takes something is 80. All right, so these are the types of problems that you'll be solving for your homework and in class and on the test. Now, what if we have 3 sets, and we want to find the union of everything? So we want to know the number of everything in A plus everything in B plus everything in C. So really we want to know everything that's in one, the other, or all 3. So let's build that formula first with our Venn diagram. A is everything that's shaded red. Okay, let's say it's A. B is everything that's shaded blue. But look, now we've counted the intersection of A and B twice, because we've counted when we counted the red, but we counted again when we did the blue. Alright, so we have to add up number of things in A plus number of things in B plus number of things in C, but we have to subtract the intersection of A and B because we counted it twice. And then when I look at the number of things in C, alright, now I've counted this region twice, which is the intersection of A and C. So I have to then subtract the intersection of A and C as well. And look at how many times did I shade the very intersection of all 3? I actually shaded that. Oh, also, so, B and C I shaded twice, so I have to erase that or subtract that because I can't count things twice if I'm trying to just find the number. And we also shaded this central part here has red, green, and blue. So I shaded it 3 times, so I have to subtract 2 of those because I counted it triple. I can only count it once. So this is our formula. A plus B plus C minus the intersection of each of the pairs, and then minus 2 of the intersection. Oh no, I already subtracted that, so then minus 1 of the intersection again where they all 3 meet. So there's our formula. Alright, so let's see that in action here. So you may be given various different regions, saying the things in A and B, which would be just right here. And you may be given all the things in C, which would be right there. And different various parts, and you may have to plug in some of the numbers here, even this, and then solve for one of the others. So here, let's say we got the leading shoe company advertises its shoes in 3 different periodicals, A, B, and C. So I'll just leave it with A, B, and C. I don't need to be too creative here. All right, so when I want to figure out the numbers in each of the various regions, so I actually have 1, 2, 3, 4, 5, 6, 7 different regions, I need to start with the intersection of everything. So it says 33 saw ads in all 3 magazines, so are 38. So that's going to be a 38. So now, the ones that saw ads in both B and C is 64. So B and C is right here. Of that 64, I've counted 38 already. So this is going to be 64 minus the 38 I already counted, which is 26. Alright? So the whole intersection is 64. 38 have all 3. 26 just has 2, B and C. So similarly, if I want to say 52 ads in both A and C, so A and C is here, I have to do 52 minus 38, which is 14. And then A and B intersection, which is this is A intersect B, that's what that means, is 84. I already got 38 here, so 84 minus 38 is 46. Where do I want to put that? 84 minus 38 gives me the 36 here. So now, how many things are in A? Well, it's 180 total saw the ad in magazine A. But of those 180, I've already counted the 46 that also saw it in B, the 38 that saw it in all 3, and the 14 that also saw it in C. So this has to be 180 minus 46 minus 14 minus 38, which gives us an 82. Alright, because I have to subtract these 3. Similarly, there were 200 in B, so I have to do 200 minus 46 minus 38 minus 26, and that gives us 90. And then for C, I have to do the total, 192, minus the ones that are already accounted for. So minus 14, minus 38, and minus 26, which gives us 114. So let me just kind of make this a little clearer. We'll circle all the final numbers here for all the various regions. Okay, now, how many customers saw ads in at least one place? Well, at least one could be 1, 2, or 3. So we got to add up all these numbers. So I add 82 plus 46 plus 38 plus 14, 90. What did I write there? 900? Yikes. 90 plus 26 plus 14. Adding all those up, and that gives us 410 saw the ad someplace. So we can answer this question now. How many people never saw the ad? Well, let's say there were 500 customers. If 410 saw the ad somewhere, that means 90, which is 500 minus 410, didn't see the ad anywhere. And then, how many saw it in exactly one place? So exactly one place is going to be these regions here. So this part indicates people that saw it in A but did not see it in any of the other periodicals. So we're going to have to add up that region plus this region plus this region. Okay, so we're only looking at here and here and here. So I add that up and I get 82 plus 90 plus 114 gives me 286. People saw it in exactly one place. All right, so there's a few examples. You should now be able to do the U-try here, which is the 6.2 self-check exercises. So you have that in your book or online. The solution's also in your book. So I'll see you next class. We'll do some more practice.